Good morning, students. Let us start with the today's class. So today we are going to discuss the lens maker's formula. Okay. Hope so. You are able to see the screen. Yes. See. So to derive the lens maker's formula, here we have the figure. So you can start copying the figure. I'll explain you what all consider here. Okay. Yes. So you can take a heading that is lens maker's formula. So for the lens maker's formula, here we are using a lens. Can anyone tell me which lens it is? Concave lens or convex lens? Yesterday I told you the different types of the lenses. So which lens it is? Yes, it is a convex lens, right? So here we are using a convex lens. Yes, very good. Okay. So we have a convex lens here. O anta en nota idira, that is the object. Okay. So what O anta en ide, that is object here. Then you are seeing the images. So if you want, name the image as, so this is, make this as image I, this as image I, and make this as image I1. So I1 is already there. Okay. So O is the object, I is the image, I1 is also a image. So the refractive index, so instead of mu1, you can take it as n1 just for clear reference aste. So n1, n2, mu1, mu2 badlagi, n1, n2 is the refractive index on the sides of the lens here. So A, B, C, you can see A here, B, C. This is one side of the refracting surface. A, D, C is the other side of the refracting surface. So radius of curvature is marked. You can see there. It is R1 and R2. Here the image distance is labeled as V1. Okay, the image distance is labeled as V1 and the object distance is taken as U. Here one more you take, that is U. VV. Here it is already there, but I don't know you are able to see or no. That is from the optic center, and the center of the mirror is called as the optic center. So this, from this optic center, the image, first image is at the distance of V. Here you can see this is V. Okay, this is V, this is V1, and here whatever the object you are placing, sorry, the lens you are placing in the same medium ala, ಎರಡು side in different refractive index iralla. So this is the refractive index. N1, and the lens is having the refractive index N2. Yes, here you can see the labelings. So N1 is the refractive index of the surrounding medium, N2 is the refractive index of the lens, O is the object, I is the first image, I1 is also the image, U is the object distance, V is the image distance, V1 is also the image distance, R1 is the radius of curvature, R2 is also a radius of curvature on different sides. Yes. Hope so diagram is clear to everyone. So once you complete the diagram, tell me. We will start with the derivation part. Shrivar, any holidays are going on again? Your college started, no? So O is the point object placed on the principal axis. N is the refractive index, N1 and N2. ABC, ADC, spherical surfaces. Okay, okay. So second PUC valuation is going on. Oh. Okay, done. See, the refractive index, radius of curvature. So let us start with the derivation, students. So please tell me, diagram is completed. So neatly copy ಮಾಡ್ಕೊಳ್ಳಿ because next derivation we are going to start. Completed, everyone? Diagram completed? Okay, so see the derivation part. Okay, in the previous class, we have formula that is refraction at one spherical surface. Okay, so the refraction at spherical surface, its formula I'm writing because for the lens, we are going to take the help of that formula now. Okay, E formula ನಿಮಗೆ ನೆನಪಿರಬೇಕು. So the later things are only substitution ಅಷ್ಟೇ. So first one. So first what we are writing, that is ಏನ್ ನಾವು ಯಾವ formula use ಮಾಡ್ತಾ ಇದ್ದೀವಿ ನೋಡಿ. So we have a formula in the previous class we have discussed. Not yesterday's class exactly. Okay. So for spherical surface, for spherical surfaces, we have the formula which is connecting the image distance, object distance, refractive index, that is given by, so first I'll write in words, that is refractive index of image divided by image distance plus refractive index of object divided by object distance which is equal to difference in the refractive index divided by radius of curvature Yes. See, so the formula from here we are going to start. So this is for the spherical mirror, the spherical surfaces, the formula which is connecting the refractive indexes and the distances, object distance, image distance, radius of curvature. So make this formula as 1. Okay. So what is the formula? Refractive index of the image divided by image distance plus refractive index of object divided by object distance, which is equal to difference in the refractive index or divided by radius of curvature. So then you by chance enadru words al bardre refractive index of the image. So image is forming at the refractive index of, suppose if you consider the image is forming at the refractive index of N1, image distance is V irutte plus refractive index of the object. Object is also placed in the refractive index of N1 and object distance is taken as what? It is taken as U, which is equal to difference in the refractive indexes. So difference in the refractive index andre lens matte object. That is N2 is for the lens minus N1 is for the surrounding divided by radius of curvature. So E formula use ಮಾಡಿ we are going to do the lens makers formula. Okay, so N1V anta ನೀವೆಲ್ಲ ಬರ್ಕೊಂಡ್ರೆ ನಿಮಗೆ ಕನ್ಫ್ಯೂಸ್ ಆಗೋ ಚಾನ್ಸ್ ಇರುತ್ತೆ. So for that reason, here I am taking the refractive index of image upon the image distance plus refractive index of object by object distance is equal to difference in the refractive index upon radius of the curvature. Okay, hope so you have copied that step. I will go for the substitution now. 2 steps ಅಲ್ಲಿ derivation ಅನ್ನ ಮಾಡ್ತೀವಿ. So let us see the first part of the derivation first. Okay, so first, so case 1 you can consider, or you can say it like refraction at the face ABC in absence of ADC. So here what we have, that is, this is the lens. Okay, so this is A and this is B, C anta nodidre, and here it is D. So ಇಲ್ಲಿ first ಏನು ನಾವು consider ಮಾಡ್ತಾ ಇದೀವಿ, refraction at ABC in absence of the ADC means here first we are going to consider first part of the spherical surface. So the first part of the spherical surface ಏನಿದೆ, that is only this much, ಹೌದಾ? That is A, this is the principal axis, this is B, this is C. In absence of the ADC ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. ಅಂದ್ರೆ ಇದೇನ್ ಲೆನ್ಸ್ ಇತ್ತು, we are not considering the other part of the lens. So lens ಅನ್ನ ನೀವು imagine ಮಾಡಿ ಕಟ್ ಮಾಡಿ only one part you are keeping it for the refraction phenomena. You have to imagine that way. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಸೊ ಸ್ವಲ್ಪ ಇಲ್ಲಿ ಇಮ್ಯಾಜಿನೇಷನ್ ಬೇಕಾಗತ್ತೆ ಈ ಡೆರಿವೇಶನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗ್ಬೇಕಾದ್ರೆ. Hope so it is clear to you what we are considering. We are considering only one part of the spherical surface of the lens. So what we are going to do now, that is the substitution. So first, here, what all we require, refractive index of the object, refractive index of the image. Then next, the distances. Yes. So according to that equation, so first term ಏನಿತ್ತು students, refractive index of the image space, refractive index of the image space. So suppose if you consider this as a lens, so this is N1 ಅಂತ ಆಗಿತ್ತು, ಇದು N2 ಅಂತ ತಗೊಂಡಿದ್ವಿ, ಹೌದಾ? So this is taken as N1 and this is taken as N2 in absence of the second surface. By chance ಏನಾದ್ರು ನೀವು second surface ಇದೆ ಅಂತ ತಗೊಂಡಿದ್ರೆ ಇದು N2 and this is N1, this is N1. So here these are N1, but here it is N2. But ಇಲ್ಲಿ ನಾವು ಈ second surface consider ಮಾಡ್ತಾ ಇಲ್ಲ. So this is taken as N1 and this is taken as N2. Okay, so for that reason, first step, we are writing the refractive index of the image space. So the refractive index of the image space, image L form ಆಗಿತ್ತು students. So in absence of the second surface, so this is A, B, C, and here we have the object O. So this is the object, the incident ray, and this is the refracted ray, and the image is forming at I. You can see there in your figure. Okay, not I, that is I1. So the image is forming at the I1 because we have I and I1. So in absence of the second bounding surface, we have the image at I1. Okay. So first, object in the ray ಬರ್ತಾ ಇದೆ, it will hit the ABC surface. Refraction ಆಗಿ ನಮ್ಗೆ image ಅಲ್ಲಿ form ಆಗ್ತಾ ಇದೆ, I1 ಅಲ್ಲಿ image form ಆಗ್ತಾ ಇದೆ. Okay students, so this is your object distance U and this is your image distance. ಏನಂತ denote ಮಾಡಿದೀವಿ for I1? Yes, what we have taken for the I1? Please check. You have the figure. What we have written for the I1? It is taken as V1, right? It is V1. Correct. So this is taken as V1. So let us substitute now. Yes. So now, according to that, here see. So first, refractive index of the image space. So image n2 del form ಆಗ್ತದೆ. So n2 divided by image distance. So image distance is what? V1. Then next, plus refractive index of the object. So refractive index of the object is n1 divided by image object distance. So object distance is u, which is equal to the difference in the refractive indexes, that is n2 minus n1 divided by radius of curvature. So for the first spherical surface, radius of the curvature will be r1. Mattondin spherical surface ide, adar radius of curvature r2 irutte students. Okay na? So this is your R1, this is my equation 2. So yarig artha aglilla, please keli, because here sign convention, one thing where I need to introduce you. So here, according to the sign convention, object distance ಏನಿದೆ, you are doing it from the left side. So object distance ಏನಿದೆ, left side ಅಲ್ಲಿ ಮಾಡ್ತಾ ಇದ್ದೀರಾ. So left side measurements are taken as what? Minus always. So this object distance will be minus. So ಇಲ್ಲಿ minus ಬರುತ್ತೆ. So ಹಾಗಾದ್ರೆ equation ಏನಾಗುತ್ತೆ? n2 divided by v1 minus n1 divided by u is equal to n2 minus n1 divided by r1. So this you can name it as equation 2 instead of the above. So which step you did not understand, please ask. So here diagram and that first formula see. Eradu tumba important agate. First gottidre, ashtu baradre, the derivation is very easy. Because we are just doing the substitution in the first formula. Yes, equation 2 is clear to everyone. So what we have done? In the formula, we have substituted the refractive index of the image upon the image distance plus refractive index of the object upon the object distance, which is equal to difference in the refractive indexes upon the radius of curvature. So, idi yav case itu? The refraction at the ABC in absence of the ADC. So, now I am going for refraction at the face ADC. So, now I am checking with refraction at ADC. So now with respect to ADC surface, so with respect to ADC surface, so here there is an object and this is your ADC surface. And here we have the two rays. So now we are not considering this is I1, this is I. So this is your figure, right? So now we gain at ADC when we are looking at the that is refraction phenomena. We are not considering O as the object. O object anta ನಾವು ತಗೊಳ್ಳಲ್ಲ. Here we will consider I1 is the object for your ADC surface. Because ಈ ಸರ್ಫೇಸ್ ಇಲ್ಲಿದೆ ಹೌದಾ? ಸೊ ಇಲ್ಲೇನಾಗ್ಬೇಕು, ಇದ್ರ ಮುಂದಿಂದ ಇಲ್ಲಿ ರೇ ಇನ್ಸಿಡೆಂಟ್ ಆಗ್ಬೇಕು ಹೌದಲ್ಲ? Not like this. So it should incident from this side. So here I1 is your object now. Actually first case ಅಲ್ಲಿ ಏನಾಗಿತ್ತು, I1 is the image. But ಈಗ second case ಅಲ್ಲಿ for ADC surface, I1 is the object. I1 is the object and the image is forming on the same side and the image is I now. Yes, in your figure, what is O, what is I, what is I1? Is it clear now, students? So O anno object enide, that is behaving as an object for ABC surface. I1 is the image for the ABC surface. And now I1 is behaving as an object for ADC surface, I1. And I is behaving as image for, or the final image anta kuda ನೀವು ಹೇಳಬಹುದು. You can say it as what? It is the final image. Curvature will be R2. So whatever you have considered here with respect to this, the radius of curvature is taken as R2. Object distance is V1. Image distance is V. So let us substitute now. Okay. So according to your formula, the refractive index of the image. So the refractive index of the image is, it is N1 divided by image distance. So image distance is V minus N2 divided by V1 is equal to N2 minus N1 divided by minus R2, minus R2. So according to sign convention, here it will come. Hope so you remember the sign convention. So accordingly we are doing that. So now this is my equation 3. So the next step will be adding equation 2 and 3. So do 2 and 3. So both the equations are there in front of you. So you can just add equation 2 and 3. So after doing equation 2 and 3 addition, see what steps you are getting. So till equation 3, if any doubt is there, please ask. Yes, 2 plus 3. So see now, so equation 2 is what? That is N2 divided by V1 minus, it is N2 divided by V1 minus N1 divided by U plus equation 3. N1 by V minus N2 divided by V1 is equal to. So if you see equation 2 and 3, N2 minus N1 is common, right? So you can write that N2 minus N1 outside, and inside the bracket what you have? Inside the bracket you have 1 divided by R1 minus 1 divided by R2. 1 divided by R1 minus 1 divided by R2. So see, any doubt is N2 divided by V1 minus N1 by U plus N1 by V minus N2 by V1, which is equal to N2 minus N1 into bracket 1 by R1 minus 1 by R2. Now you can see which term will get cancelled or all will remain as it is. Check. 1, 2, 3, 4. First LHS side, RHS side. Sorry, LHS side, see which terms will get cancelled. Yes, right. N2 by NV1, you can see it will get cancelled, students. So N2 by V1, it will get cancelled. So now, what is remaining? That is N1 by V minus N1 by U, which is equal to N2 minus N1 inside the bracket. It is 1 by R1 minus 1 divided by R2. Yes, see. So the remaining term is N1 by V minus N1 by U is equal to N2 minus N1 into bracket 1 by R1 minus 1 by R2. Okay, so again, what is common here? N1 is common, right? So what is remaining? That is 1 by V minus 1 by U is equal to N2 minus N1 inside the bracket. It is 1 by R1 minus 1 divided by R2. Okay, so what is 1 by V minus 1 by U? Anybody remember? Lens formula prakara 1 by V minus 1 by U. ಏನಂತ ಬರಿಬಹುದು? ನಿನ್ನೆ ಲಾಸ್ಟ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ ನೋಡಿ.
One by F.
Yes, it is 1 by F. So according to the lens formula, not lens makers, okay, it is 1 by F. So I can write it as what? N1 by F is equal to, this is N2 minus N1 inside the bracket. It is 1 by R1 minus 1 divided by R2. Correct? So now what I can do here is, that is whatever this formula is also called as Newton's lens formula anta kuda ಹೇಳ್ತಾರೆ. So now here we will do one consideration, that is lens is having the refractive index. ಈ derivation ಅಲ್ಲಿ lens refractive index N2 1, correct students? So if I consider just last consideration, last one step, suppose the refractive index of the lens instead of N2 N anta ಇದೆ ಅಂತ ತಗೊಳ್ಳಿ, and this is surrounded by the vacuum. Lens vacuum in the surrounding ಆದಾಗ N1 is equal to ಎಷ್ಟಾಗತ್ತೆ? Or air. What is the refractive index of the air? In 10th standard also you have studied. What is the refractive index of the air? It is 1. Very good. So the refractive index of 1, therefore N1 is equal to 1 anta substitute madana. So see what happens with your derivation. The last step, N1 is equal to 1 upon F is equal to, so N2 minus N1. So N2 is taken as N minus N1 is taken as 1. So it is N minus 1. And inside the bracket, here we have 1 by R1 minus 1 divided by R2. So this is our that is lens maker's formula. So see the lens maker's formula. 1 by F into bracket, 1 by F is equal to N minus 1 into bracket 1 by R1 minus 1 by R2. So ನೀವೇನಾದ್ರೂ ಈ derivation copy ಮಾಡಿದ್ರೆ, you can see how much big it is, but nothing is there in the derivation. So first ನಾವು ಏನೊಂದು formula ಹೇಳಿದ್ವಿ ನೋಡಿ students, that is very very important. That is refractive index of the image upon the image distance plus refractive index of the object divided by object distance is equal to difference in the refractive index upon the radius of curvature. This formula is very very important. Then after that you are just doing the substitution. So ನಿಮಗೆ clear ಆಗಿ ಗೊತ್ತಿರಲಿ N1 N2 L ಬರುತ್ತೆ ಅಂತ, because if you do mistake there, again the derivation will go wrong. Correct? So any doubt is there, please ask. So R1 is positive because it is right side measurement. R2 is negative because it is from the left side measurement. So with respect to the sign conventions, plus minus ಎಲ್ಲ ನೀವು ಪ್ಲೀಸ್ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. ಸೊ ಮಿಸ್ಟೇಕ್ ಆಗೋದು ಆ ಪಾಯಿಂಟ್ಸ್ ಅಲ್ಲಿ ಮಾತ್ರ, ಬಾಕಿ ಎಲ್ಲ ಏನ್ ಮಿಸ್ಟೇಕ್ ಆಗಲ್ಲ. ಸೈನ್ ಅನ್ನು ನೀವು ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಬಹುದು. ಸೊ ಬೈ ಚಾನ್ಸ್ ಇಫ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ರಾಂಗ್ ಇನ್ ದ ಡೆರಿವೇಶನ್, ನೀವು ಇಲ್ಲಿ ಬಂದ್ಮೇಲೆ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗತ್ತೆ ನೋಡಿ ಈ ಸ್ಟೆಪ್ ಅಲ್ಲಿ. ಇನ್ ದಿಸ್ ಸ್ಟೆಪ್ ಯು ವಿಲ್ ರಿಯಲೈಸ್ ವೇರ್ ಯು ಹ್ಯಾವ್ ಗಾನ್ ರಾಂಗ್. ಬಿಕಾಸ್ ಇಲ್ಲಿ ಏನಾಗ್ಬೇಕು, ನಮ್ಮ ಹತ್ರ ಏನ್ ಉಳಿಬೇಕು, N1 ಟರ್ಮ್ ಮಾತ್ರ ಉಳಿಬೇಕು. ಹೌದಾ? ಸೊ ಆವಾಗ ನೀವು ಇಲ್ಲಿ ಕ್ರಾಸ್ ಚೆಕ್ ಮಾಡ್ಬೋದು ಎಲ್ಲೇನಾದ್ರೂ ಮಿಸ್ಟೇಕ್ ಆಗಿದ್ಯಾ ಅಂತ. ಸೊ ವಾಟ್ ಎವರ್ ದ ಡೆರಿವೇಶನ್ಸ್ ಯು ಆರ್ ಸೀಯಿಂಗ್, ಸೊ 1-2 ಟೈಮ್ಸ್ ವಿದೌಟ್ ಸೀಯಿಂಗ್ ಬರ್ದಿ ಹೀಗೆ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿಟ್ರೆ ಎಕ್ಸಾಮ್ಸ್ ಟೈಮ್ ಅಲ್ಲಿ ಅಷ್ಟು ಟಫ್ ಆಗಲ್ಲ. ಓಕೆ, ಯಾವ ಲೆಸನ್ ನಡೀತಾ ಇರತ್ತೆ, ಪ್ರಾಕ್ಟೀಸ್ ದೋಸ್ ಡೆರಿವೇಶನ್ಸ್. ಸೊ ಸೈಮಲ್ಟೇನಿಯಸ್ಲಿ ನೀವು ಅದೊಂದು 2 ಸಲ ಬರ್ದಿ ಮಾಡಿಟ್ರೆ ಕಡೆಗೆ ನಿಮ್ಗೆ ನೆನ್ಪು ಉಳಿಯುತ್ತೆ ಅದು. ಓಕೆ, ಎಸ್, ಎನಿ ಡೌಟ್ ಇಸ್ ದೇರ್ ಇನ್ ದ ಡೆರಿವೇಶನ್? ಸೊ ನೀವೀಗೇನ್ ಹೇಳ್ಬೋದು, ದ ಫ್ಯಾಕ್ಟರ್ಸ್ ಆನ್ ವಿಚ್ ದ ಫೋಕಲ್ ಲೆಂತ್ ಇಸ್ ಡಿಪೆಂಡಿಂಗ್. ಬಿಕಾಸ್ ಫೋಕಲ್ ಲೆಂತ್ ನಮಗೆ ಫಾರ್ಮುಲಾ ಬಂದಿದೆ, 1/f is equal to n-1 into bracket 1/r1 minus 1/r2. ಹೌದಾ? ಸೊ ಹಾಗಾದ್ರೆ ಫೋಕಲ್ ಲೆಂತ್ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ. ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದಿ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಆಫ್ ದ ಮಟೀರಿಯಲ್ ಆಫ್ ದ ಲೆನ್ಸ್, ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಆಫ್ ದ ಸರೌಂಡಿಂಗ್. ಬಿಕಾಸ್ ನಮ್ದು ಫಾರ್ಮುಲಾ ಏನ್ ಬಂದಿತ್ತು, n2 minus n1 ಅಂತ ಇತ್ತು. ಅಲ್ಲಿ ನಾವ್ ಏನ್ ಮಾಡಿದ್ವಿ, ಲೆನ್ಸ್ ಅನ್ನ ಏರ್ ಅಲ್ಲಿ ಇದೆ ಅಂತ ಇಮ್ಯಾಜಿನ್ ಮಾಡಿ n1 is equal to 1, n2 is equal to n ಅಂತ ತಗೊಂಡಿದ್ವಿ. ಹಾಗಾಗಿ ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಆಫ್ ದ ಲೆನ್ಸ್, ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಆಫ್ ದ ಸರೌಂಡಿಂಗ್, then it depends on the radius of curvature or radii of curvature, because r1 r2 ಎರಡು ಇದೆ. It depends on the radii of curvature and it depends on the wavelength of the light also. As it is depending on the refractive index and all, it is depending on the wavelength also. Yes, everybody copied the derivation and the diagram. If any doubt is there, please ask. Last 2 small points we are discussing and we will end it. Yes, completed. Done. Okay. So the next one we are seeing, that is the power of the lens. So what is power of the lens? Already power you have studied for the mirror. So power of the lens, power of the mirror, it is almost the same formula. The power of the lens or the power of the mirror, really it is the reciprocal of the focal length. Okay, the reciprocal of the focal length will give you the power of the lens. So you remember here, ಪವರ್ ಯಾವಾಗ ಪಾಸಿಟಿವ್ ಯಾವಾಗ ನೆಗೆಟಿವ್ ತಗೊಳ್ಬೇಕು ಅಂತ ಅಂದ್ರೆ, ದ ಪವರ್ ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಇಟ್ ಆಸ್ ಪಾಸಿಟಿವ್. ಪವರ್ ಪಾಸಿಟಿವ್ ತಗೊಳ್ಬೇಕು ಯಾವಾಗ, ವೆನ್ ಯು ಆರ್ ಯೂಸಿಂಗ್ ಎ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್. So convex lens ಗೆ the power value will be positive and the power will be negative for the concave lens. For the concave lens, the power will be taken as negative. Okay, concave lens ಗೆ negative ಇರುತ್ತೆ, convex lens ಗೆ positive ಇರುತ್ತೆ, and it is nothing but the reciprocal of the focal length. So what is the unit of the power here? See here students, the unit of the power is, anybody knows the unit is, it is the diopter. See. So in 10th standard you have studied this. The unit is diopter and it is denoted by the letter capital D, diopter. Okay. Then the next point, that is the magnification. So the magnification is denoted by the letter M. Already mirror idella madidvi, just for lens also separately we are defining. So the magnification to the height of the, height of the image to the height of the object. Height of the image to the height of the object. Then next, the magnification is also written as what? That is V divided by U. Mirror ಅಲ್ಲಿ ಏನಾಗತ್ತೆ? It is minus V by U, and in case of the lens, it is V by U. It is just V by U. Minus is not there. So magnification is not having any unit. I told you last time also. So suppose if you are getting the magnification is greater than 1, we are getting the magnified image. So namge magnified image baratte. If the magnification is less than 1, it is a diminished image. It is the diminished image. Yes. So this completes the lens makers formula, students. So the next point will be, that is the combination of the lenses, focal length formula adon nodana, and some of the defects, and we will go for the optical instruments. So other 2 classes I require, we will finish this lesson. Okay. So we will meet in the next class with the next points. Yes. If any doubt is there in the today's class, ask. Otherwise, bye students. Thank you.